Hey guys, today we're going to talk about writing the equation of a sinusoid based on the graph. So I shared this document with you guys on Schoology. It has some graphs, and we're going to go through and figure out all this information to help us get the actual equation that can model it. So, I always break it down to certain points. Like we can easily tell how high our maximums are. Our maximums are 4 high. And how low our minimums are. Here it's -2. So the total height from -2 to 4, that total height is 6. But that total height is not the amplitude. The amplitude is the distance from the top to the middle, or the bottom to the middle, so that's half the total height, so the amplitude is 3. All right? So half the total height is your amplitude, and exactly in the middle is your axis of the wave. So halfway between 4 and -2, that's here. It's 3 below 4, 3 above -2. That's at 1. So our general equation, it looks like y equals a, and then either sine or cosine. It doesn't matter. We're going to actually do both a sine and a cosine. But b times x minus h plus k. So this is our general form. All right? Well, the amplitude, that's a. And the axis of the wave, that's k. So we already have two parts of it. So the amplitude helps us find out a, the axis of the wave helps us find out k. Now we just need b and h. Well, b comes from our period. Our period is 2 pi over b. So in this case, our period is 1 full cycle. On a graph, personally, I find the easiest way to do 1 full cycle is to go from a maximum to a maximum. So this maximum is at pi over 4. This maximum is at 5 pi over 4. So the distance between pi over 4 and 5 pi over 4, you subtract them. 5 pi over 4 minus pi over 4 is 4 pi over 4, which is just pi. So our period is pi. So our period is pi, and the period equals 2 pi over b. So if we solve that equation for b, multiply both sides by b, pi b equals 2 pi. Divide both sides by pi, you'll be left with b. Well, 2 pi divided by pi means b equals 2. So we found a, we found b, we found k. All that's left is h. So that's going to give us our phase shift. So it's a different phase shift if you're doing a sine or a cosine. Let's talk about the sine first. A sine function starts at the axis of the wave. If it's positive, it's going up. If it's negative, it's going down. So these are the points where it hits the axis of the wave. All right, so we could choose any of those. At the places where it's going up, it will be a positive sign. At the places it's going down, it will be a negative sign. Personally, if I have the option, I always choose to do a positive. So if it's a positive sign, I could choose this, I could choose this, or I could choose this, because it's at the axis of the wave going up. And your phase shift, your h, is just whatever your x value is there. So the x value here is 0. The x value here is pi. The x value here is 2 pi. We could do any of these three. But honestly, if you have 0, choose 0. Why choose anything else if you can just have x minus 0, which is just x? So we have 0 as h, we have 2 as b, we have 3 as a, and 1 as k. So we just fill everything in. 3 sine of 2x minus 0 plus 1. Okay. A sine of b times x minus h plus k. If you didn't have those extra parentheses around the x, that's perfectly fine because it's just 2 times x inside there. All right, so now the cosine. The cosine, the phase shift, if it's a cosine, it's where it's at a maximum or a minimum. If it's a positive cosine, it's at a maximum. If it's a negative cosine, it's at a minimum. So I always like to do the positives. So if it's a positive, I'm just going to look for where it's at maximum. So it's at maximum here, here, here. Then there will be 1 over here, but that's off the grid. So our phase shift, our h, is just the x-coordinate of any of those points, and any of them would work. So that's pi over 4. We could have pi over 4. We could have 5 pi over 4. And this one back here is negative 3 pi over 4. So we can choose any of them. I usually like to choose the one closest to 0, so I'm going to choose pi over 4. But you could easily have 5 pi over 4 as negative 3 pi over 4. So your equation of your cosine, it's y equals a, which is 3, cosine of b, which is 2, times x minus h, so x minus pi over 4, plus k, plus 1. All right. So let's try another one. So if we look at this one down here, our maximums are at 1. Our minimums are at negative 3. So the total height from negative 3 to 1 is 4, but the amplitude's just half of that. Because the amplitude's the distance between the axis of the wave to the maximum or the axis of the wave to the minimum. So half of 4 is 2. And that's a, because our equation is y equals a sine or cosine of b x minus h plus k. So a is our amplitude, and k is our axis of the wave, which is halfway between the maximums and the minimums. Halfway between 1 and negative 3 is negative 1. So that's k. So we've got a, we've got k. Now to find b, we use our period, and our period equals 2 pi over b. So this time our period, from maximum to maximum, we've got a maximum at negative pi over 2. We've got a maximum at 7 pi over 2. So the period is the distance between them. 7 pi over 2 minus negative pi over 2. Subtracting a negative is the same as adding a positive, so it's 8 pi over 2, which is 4 pi. So that's our period. So our period equals 4 pi over 2. Well, if the period is 2 pi over b, not 4 pi over 2, just 4 pi, sorry. If the period's 2 pi over b, multiply both sides by b. 4 pi b equals 2 pi. And then to get b by itself, you would divide by 4 pi. So 2 pi divided by 4 pi, the pi's divide off. And 2 over 4 simplifies to 1/2. So now we've got a, b, and k. All we need is h. So for a sign, always figure out whether you want it to be a positive or a negative sign. Like I said, if you can choose to do a positive sign, do a positive sign. If you can choose to do a positive cosine, do a positive cosine. So a positive sine, it's at the axis of the wave where it's going up. So it would be either here or here for a positive sine. This one, it's off the grid, so I'm not going to use it, but this one, it's 5 pi over 2. So that's going to be h. Normally, if there was no phase shift, this point would be on the y-axis, but we've moved it right 5 pi over 2. So that's h. So we have a, b, now h and k, and we just fill in. Y equals a, which is 2, sine of b, which is 1/2, times x minus h, which was 5 pi over 2, plus k, which was -1. So this equation models that function. For the phase shift for the cosine, I choose to do a positive cosine. So a positive cosine starts at the maximum, so we look for the maximums, here or here. So we can do negative pi over 2 or 7 pi over 2. Either one. Either one can be your h. I'm just going to choose to do the one that's closer to 0, the negative pi over 2. So a, b, and k are still the same. So 2 cosine of 1/2 x, and then it's minus negative pi over 2 rather. So plus pi over 2, and then minus 1. So these two equations both model that same graph, just in different forms. A's are the same, B's are the same, K's are the same. The only difference is what your phase shift is. Let's do one more together, and then if you guys want some extra practice, you can do the last one on your own. So, this one, our maximums, it's halfway between 1 and -2, so -3/2. -3/2. And our minimums are halfway between -2 and -3, so that's -5/2. So the total height of it is 1, between -3/2 and -5/2. Oops. That's 1. So half the height is half of 1, 1/2. The axis of the wave is smack dab in between. I didn't draw it very well, but it's just at -2. So that's a, and that's k. In our equation, y equals a sine or cosine b x minus h plus k. So we have a, we have k. And b we get from our period. Our period is 2 pi over b. So this time our maximums aren't at lattice points, but our axis of the wave is at a lattice point. Here and here. Oh, no, cat, go away. Sorry about that. That was my kitty. He wants to cuddle, but I'm busy. So we're at the axis of the wave at -4. We're at the axis of the wave at 6. So that's one full period from -4 to 6. So one full period is 10. So 10 is what equals 2 pi over b. So 10b equals 2 pi. Divide both sides by 10. Bless you. And b equals pi over 5. So we have a, b, and k. All that's left is h. For a sine, it's at the axis of the wave. For a positive sine, it's at the axis of the wave going up. So at -4 or 6. Now, we can choose either one. I'm just going to choose -4. Doesn't matter. You could easily do 6. It's okay. So we just plug everything in. Y equals A, which was 1/2. Sine of B, which was pi over 5. X minus h, so x minus -4 is x plus 4. If you had x minus 6, it'd be perfectly fine and give you the same graph. And then plus k, so minus 2. For the cosine, this is where it gets a little tricky because it's not at a lattice point. But now we think back to what our pattern was. Every quarter of a period, we go through our pattern. So quarter of a period is 10 over 4, 5 over 2. So if you add 5 over 2 to -4, that brings us maximum at -3 over 2. So we can use that maximum. Or you could go 3 over 2 beyond here, and that's 15 over 2. And either one works. So if we do our equation, I'm just going to choose to do that one. Y equals A cosine of B times x minus h plus k. Again, A, B, and k are the same. The only things that change are the h. All right. Hope that makes sense. Have fun. Bye.